Adding mixed fractions. There are two ways in which we can use to add mixed fractions, and we're going to learn both of them today. So the first method that we're going to use is converting our fractions into improper fractions before we actually add them. So that will be our first method, and so I'm going to grab my pen here, as I usually do, and we're going to get started. So we've got 3 and 1 over 4 plus 3 and 5/8. So by converting these into improper fractions, we need to multiply the denominator times the whole number and add the number on top. So add the numerator. So in this case, our first fraction is 4 times 3, which is 12, and we add the 1 on top, we've got 13, and we leave the denominator the same. Then we have our other fraction, and 8 times 3 is 24, and when we add the 5 that we've got there on top, it becomes 29, and we leave the denominator the same. Now, if we remember, when we're adding fractions, we can't do anything unless our denominators are the same. So we notice that now in our fractions, our denominators are not the same. So we need to make them the same before we continue. So in order to make them the same, we're going to look at this 4, and we know that if we multiply 4 times 2, we can get an 8, and that would give us the same denominator. But our rule of thumb is whatever you do to the bottom, you must do to the top. So if we're going to multiply the bottom by 2 so that we can have the same denominator, we need to multiply the top also by 2. So then this becomes a 26 because 13 times 2 is 26. And this is an 8 because 4 times 2 is 8. We didn't have to do anything. I mean, in reality, we're just multiplying by 1. So when we multiply by 1, we don't really need to do anything. So this stays 29 over 8. Now, someone may look at me and say, well, why did you just multiply by 1? I multiplied by 1 because technically the 8 is already an 8. I mean, you have to multiply 8 times 1 to get an 8. So this is why we multiply by 1 to get an 8. And whatever we do to the bottom, we do to the top. But usually, if we're not changing our denominator, we just don't have to do anything. We just leave it the same. And we assume we're multiplying by 1. Okay, so now we've got the same denominator on both of these fractions. So we can now put them both under 8. And we can add the top. We can bring our 26 over here, plus our 29, and that gives us 55 over 8. Now you'll notice that our result is still in an improper fraction format, so we need to change it back to mixed number because we were adding mixed numbers. And so to do that, we're going to apply our conversion rules. And how do we do that? We divide the 55 by the 8. And so the closest number in the 8 times table to a 55 is a 6. Now let's go on the side right here so that we show how we did that. If we go 8 times 6 equals 48. 8 times 7 is 56. Whoops. 8 times 8 is 64. And if we go one number lower here is 8 times 5 equals 40. So the closest number to our 55 without going over is right here, 8 times 6. So this is why we've got our whole number 6. So 8 goes into 55 6 times, and we end up with a remainder of 7. So we put our 7 at the top, and our denominator remains the same. So this is the way that we solve it by converting our fractions into improper fractions. Okay, now let's look at the other way that we could add mixed fractions. The other way that we're going to do it is by adding the whole numbers on the side and adding the fractions on the other side and then just kind of joining them together. So let me get my pen. All right, we are ready to go. So we've got here 3 1/4 plus 3 and 5 over 8. So the first step is we are going to add our whole numbers. So we've got a 3 and a 3, and 3 plus 3 is 6. So we're going to leave those to the side. We're not going to do anything with it yet. And I'm going to add a bracket. And the reason that I'm going to add a bracket is so that we remember that we want to leave the 6 aside. We don't want to touch it. Okay, we've already added our whole numbers. Let's have an equal sign here so we show our steps. Okay, now we can write our fraction. And so our fractions are 1/4 plus 5/8. Okay. And we're going to focus only on the fractions. We're going to leave our 6 still on the side. We're not going to touch it. We're just separating it with a bracket for the time being. Okay, and so now the rules are the same. In order to add our fractions, we need to have the same denominator. Doesn't change from the way we solved it before. So the common denominator for both of them is 8, because 4 can go into 8 by multiplying it by 2, and 8 can go into 8 by multiplying it by 1. So that is a common denominator in both timetables. So we're going to multiply this one by 2, and whatever we do to the bottom, we do to the top. And so our new fraction becomes 2, because 1 times 2 is 2, over 8, plus 5 over 8. We leave this as is because, like I said, we're just multiplying this 8 by 1, and whatever we do to the bottom, we do to the top. Okay, let's go to the next step. We bring over our 6 that we're leaving on the side for the whole number. And since we have the denominator the same, we can leave our 8 at the bottom and bring down our numerators. So 2 plus a 5. So when we add that together, now we can remove our bracket, because now we've solved our fraction side. So we're going to leave our 6, remove the bracket, and this becomes 7 over 8, which is the same answer we got when we solved it by adding improper fractions. Okay, why don't we try another example? So we now have 4 and 3 over 6 plus 2 and 2 over 8. And so we need to add those mixed fractions. So let's get started. Okay, so if we notice, we can actually reduce these fractions before we get started. And so that can make it a little bit easier for us. So why don't we actually start by doing that? So I'm just going to rewrite the question. So we've got 3 over 6 plus 2 and 2/8. And so we're going to try to just find an equivalent fraction for both of these, because we can actually reduce them. So if you'll notice, both of these numbers are divisible by 3. 3 goes into 3 once, and 3 goes into 6 2 times. So we can actually make these numbers smaller. This becomes a 1, and this becomes a 2. Same thing here. Both of these numbers can be divisible by 2. 2 goes into 2 1 time. 2 goes into 8 4 times. Okay, so we've just made it smaller. You don't have to do this. You can keep them the way that they are and do your equation, but it just helps us keep the numbers small. Okay, let me now rewrite the question. So now we have 4 and 1/2, and 1/2 is an equivalent fraction of 3 over 6. And we'll have another video to try to remember what equivalent fractions are all about. And we've got the 2, and we've reduced the 2/8 to 1/4. Like I said, you don't have to do this. It's just going to make it easier for you when we're converting into improper fractions and we're using such big numbers. Okay, so now we're ready. So the first method that we're going to use is converting to improper fractions. So we do that by multiplying the denominator times the whole number, so that gives us 8, and adding the top, which gives us a 9. So this becomes a 9 over 2 because our denominator always stays the same when we're converting to improper fractions. Okay, we have our plus sign, and now we're going to do the same thing to this one. We need to keep them both improper if this is the way that we're going to go. So we're going to multiply the denominator times the whole number, which is 4 times 2, which is 8. Then we add the 1 on top, which is 9 over 4. Now, don't start adding yet. Remember, our denominators must be the same before we add. It's very important. A lot of people get adding fractions wrong because they forget that very important step. In adding and subtracting, your denominators must be the same. So how do we get this denominator to be the same? Well, we need to find a common denominator. So that means that there's a number in the 2 time table that is also found in the 4 time table. And that number is 4, because 2 times 2 is 4 and 4 times 1 is 4. So both timetables actually have the number 4 in it. So we're going to multiply this 2 times 2, because that way we can actually get to the 4 that we need to have at the bottom. But whatever we do to the bottom, we need to do to the top. Okay, now are we doing anything to this fraction? We really aren't. But if you feel better showing a multiplication, it would be a 1, because 4 times 1 is 4, and whatever we do to the bottom, we do to the top. So now let's write our new fraction. So 9 times 2 is 18, and 2 times 2 is 4, plus 9 times 1 is 9, and 4 times 1 is 4. Okay, so now we have both denominators the same. So now we can actually put this all over a 4, which becomes 27, because 18 plus 9 is 27. Now we need to change this now back to being a mixed fraction, because we were adding mixed fractions to begin with. All right, so in order to do that, we are now going to divide the 27 by the 4. So what number in the 4 times table gets us closest to the 24? That would be a 6, because 4 times 6 is 24. Sorry, we need to get close to the 27, not 24. So 4 times 6 is 24. So that's as close to the 27 as we can get, because if we multiply 4 times 7, we get a 28. That's already above our 27, so we can't use that. But 4 times 6 is 24, which is really close to 27. And we end up with a remainder, and our remainder is 3, and we leave that under our denominator of 4. So that is if we use improper fractions to solve the mixed fraction. Now, what if we don't use an improper fraction and we want to solve it using the other method? Okay, so let's write our question one more time. Okay, so same thing. I mean, you can leave these fractions the way they are and deal with reducing at the very end. So simplifying your answer, that's really what's going to end up happening. You're going to have to simplify it further to get to have it reduced. Or you can do it right now by reducing it from the very beginning using an equivalent fraction. So this will become a 1 and a 2, because 3 is divisible into both numbers. So 3 goes into 3 once, 3 goes into 6 2 times. Same thing here. 2 goes into 2 once, 2 goes into 8 4 times. Now we can write our new fractions, and we have a 4 and 1/2 plus 2 and 1/4. Okay, so like we said, in this method, we're actually going to add the whole numbers together. So we're going to end up with a 6, and then you can have a little bracket to separate the rest of the fraction. So we have 1/2 plus 1/4. So you'll notice we have our whole numbers on the left, and we've got our fraction here. So we're going to leave our whole number as is. We're not going to touch it. We're just going to keep bringing it over with us, and we're going to solve the fraction. So again, we do not have the same denominator, so we need to solve that first. In order to make the addition, we need to find a common denominator, and the common denominator in this case is 4, because both the 2 time table and the 4 time table have a 4 in it. 2 times 2 is 4, 4 times 1 is 4. So let's multiply this by 2, multiply the top by 2, the 4 we multiply by 1, and 1 times 1. Okay, so now we get a 2 at the top because 1 times 2 is 2, and at the 4, a 4 at the bottom because 2 times 2 is 4. We're adding here. Now the top here becomes a 1 because 1 times 1 is 1, and this is a 4 because 4 times 1 is 4. Okay, now we have the same denominator. Now we can add both of these numbers, and we keep bringing our 6 over. We're not touching our 6 yet. So this becomes 2 plus 1 all over 4, which is the same as, we can bring our 6, and now we can remove the bracket, 3 over 4. So you'll notice we got the same answer no matter the method that we use. Just up to you what's easiest for you. I kind of like the separating the whole numbers first, but it can get tricky when you have a lot of fractions to add, but I find it's a little bit cleaner, but it's up to you. They both give you the same answers.